So hello everyone, let us solve another LeetCode problem, and the problem name is number of centered subarrays. So you are given an integer array nums. A subarray of nums is called centered if the sum of its elements is equal to at least one element within the same subarray. In the end, we need to return the number of centered subarrays. So what the question is saying that a particular subarray of nums is called centered if sum of all the elements inside that subarray is equal to at least one of the element which is actually present inside it. So how it can be possible? Obviously, if we have some negative elements, then only this sum can be equal to one of the elements, or if there are zeros present, then only we can have this particular thing possible. Now this is actually marked as medium, but this is actually an easy problem because the constraints are so low that we can just apply the brute force method and just check on each and every subarray and solve this particular problem. So let us see this first example. This first example is -1, 1, 0. So what we can do, we can just compute all of the subarrays, and for each and every subarray we can like keep an unordered map which can keep track of the elements, and one sum variable which can keep on taking the sum, and we can just check whether at some point our sum is equal to some element that is already present inside our map or not. So just use I and j variable in the brute force approach. Just go and check each and every subarray, just compute its sum and check whether this sum is present inside this unordered map or not. Simply the brute force approach. So there is nothing much to dry run. This is self-explanatory code. So let us just directly see the code now and understand what it is actually doing. So yeah, this is the code, a very simple basic brute force approach I have just applied here. So brute force approach is there. So n is the num size, answer is the total answer that we can get, total number of such subarrays that we can get. Now we are just going on to each and every subarray where I is going from 0 to n and j is going from I to n. The same way, I is here and j is also initially here, then j will be here, so this will be the subarray, then j will be here, so this will be the so on and so forth. This is what I am saying. So we are just going on to each and every subarray. So we are going on to each and every subarray, and for each and every subarray we are like declaring one map and a sum. This sum will keep track of the total sum that we are getting inside the subarray, and this map will keep track of the number of elements free or the elements that are present inside the current subarray. In the end, we are just checking if the sum is present inside the map or not. If it is present, we are just incrementing the answer because we got one subarray whose sum is equal to one of the elements that are already present inside that subarray. In the end, after doing this operation to each and every subarray, we are just returning the answer that we can get. So yeah, pretty much easy problem, nothing hard and nothing much to explain. But yeah, I hope you understand this solution. Thank you for watching.